Welcome to my YouTube channel, A Brainery of Civil.
In this video, I am going to solve the first assignment of matrix methods of structural analysis. I think in the civil engineering, the most toughest part is matrix methods in the structural analysis. Okay, so I am going to solve the problems related to that. Are you ready? Let's start. For the following frame, number of static and kinematic indeterminacy is, in bracket, ignore axial deformation. So first of all, he asked to calculate degree of static indeterminacy and degree of kinematic indeterminacy. So now, degree of static indeterminacy, we have a formula for frame 3C. Here C is equal to number of cuts required to form a cantilever. Okay, so I made one cut here, one more cut here, one more cut here, and this entire portion will become one cantilever beam. Okay, and similarly I made one more cut here, 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 here. This entire portion will become one more cantilever beam, provided we need to provide two reactions. Generally, this is fixed 3 number of reactions. This is roller, only one reaction. We need to restrain moment and we need to restrain horizontal deflection. That is -2 here we need to provide. Similarly, here -2 we need to provide. So now total number of cuts required to form a cantilever are 6 number of cuts. So C is equal to 6. So it will become 3 into 6 minus, that is at A and B we need to provide extra support reactions to make it cantilever. -2 at A, -2 at B. So that is 18 minus 4, it is equal to 14. So degree of static indeterminacy is 14. So you can see it in option 4 and option 2. Now we need to calculate degree of kinematic indeterminacy. So dk. Generally the definition of dk is number of independent displacements at all the joints in a structure is called degree of kinematic indeterminacy. That is number of independent displacements at all the joints in a structure is called degree of kinematic indeterminacy. Here there are 1 joint, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 joints. Out of 12 joints, these joints, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 joints will produce one rotation only, because he mentioned that axial deformations are 0. Okay, so when axial deformations are 0, so at these 9 joints, when I mark like in the red, 9 joints, one rotation, that is 9 into 1, and there is one more rotation here at theta A and theta B. So 9 into 1 plus it is 11 total. Okay, and at this level delta x, at this level delta x, at this level delta x. 3 deformations, axial deformations, that is this portion one delta x, this portion another delta x, but these delta x1 and delta x2 both are equal, that will be equal to delta x at top level, because when axial deformations are neglected, we need to consider only one horizontal deflection at top, at middle, at bottom. So 3. So 9 plus 2 plus 3, it is 14. Okay, so the degree of will become 11 plus 14, and here one more delta x, here one more delta x at point A and B. Okay, so total this 14 will be added to 12, it is 16. So the answer will become 14 and 16. Okay, so this might be confusing. I'll explain once again. So you can see here, at all the number of independent displacements at all the joints in a structure is called degree of kinematic indeterminacy. The independent displacements are either they may be delta x, delta y, theta. Okay, so first theta, 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 here theta, here theta. There are total 11 thetas. Okay, rotation at each joint. And here delta x, delta x, delta x, and 3 delta x at 3 different levels, and one more here delta x, here delta x, because it is a roller, delta rotation will be possible. Okay, and horizontal deflection will also 2 delta x. So 11 plus 5 will become 16. I hope you can able to understand this explanation. So the answer will become B for question number 1. Okay, and for the following beam, number of static indeterminacies, degree of static indeterminacy is equal to R minus S. So that is number of reactions minus equilibrium equations. So how many number of reactions? So at supports number of reactions will exist. Here number of reactions 3, here number of reactions 3, here number of reactions 1, here number of reactions is equal to 1. Total how many number of reactions? There are 3 plus 3 plus 2. It is 8 minus generally equilibrium equations S is equal to sigma fx, sigma fi, sigma mz. These are all is equal to 0. Whenever we are providing one roller, intermediate roller, that is hinge support, intermediate hinge, we will provide one additional equation, that is 1 here, 1 here, 1 here. So 3 plus 3 will become 6. So you will get degree of static indeterminacy is 2. So that is option 1. Clear? And number of static indeterminacy for the following truss. Number of static indeterminacy, degree of static indeterminacy for a truss is equal to m plus r minus 2j. How many number of members? 1, 2, 3, 4, 5, 6, 7 members are there. And number of reactions 2 here, 1 here, 3. Minus 2 into number of joints. Here 1 joint, 2, 3, 4, 5. 2 into 5. It is 10 minus 8 number of members are there. Okay. So it is 11 minus 10. That is degree of static indeterminacy is one option. Second one is the answer. So these are all simple problems. And coming to next question. A slider kind of connection is shown below. Choose the correct free body diagram. Choose the correct free body diagram means this is a roller support. We call it is generally it is a guided roller. Okay. So it will not allow horizontal movement. So that is delta, there is a horizontal reaction here. So RH is there and there is momentum. Okay. So this moment it may be a clockwise or depending upon the load that we applied in which direction. So the corresponding answer is this one. Clear? So that is second one. And coming to next question. Pin jointed structure A, B, C as shown in figure. Find horizontal reaction at A. Joint B is also a pin. Joint B is also a pin. That is the most important. Okay. At A there is one vertical reaction. At A horizontal reaction we call it is HA and RA, and this is RC and it is HC. So we will take basic equilibrium equations. I am going to take sigma fx is equal to 0. HA minus HC is equal to 0. From this I can able to say HA and HCA both are equal. And sigma Fy is equal to 0. RA plus RC is equal to 10 into 3 is 30 kilonewton. I am taking moment about sigma MC is equal to 0. This RA will create positive and HA will create negative and 10 kilonewton load will create negative anti-clockwise. So RA into 5 minus HA into 2 and minus 10 into 3 by 2 is equal to 0. This is one equation, equation number 1. I am going to take sigma moment about point B is equal to 0. RA into 2 minus HA into 2 is equal to 0. So from this we can say RA is equal to HA. Clear? What we want ultimately, he asked horizontal reaction at A. So you can substitute this R in place of RA HA. 5 HA minus 2 HA, it will become 3 HA minus 30 into 3 by 2 is equal to 0. 3 will get cancelled. So HA will become 15 kilonewton. Very important. Even though the ends are fixed, but he has given some internal pin at point B. So that's why we can able to solve this problem. Otherwise it will become indeterminate structure. So the answer will become 15 kilonewton. It is option 3. And now for the following structure, question number 6. A is fixed and B and D are pinned. Joint C is a rigid joint. Now choose the correct option regarding degree of static indeterminacy. Obviously in the first problem I explained degree of static indeterminacy is for a frame it will be 3C, that is 3 into the number of cuts required to form a cantilever. C is equal to number of cuts required to form a cantilever. I made one cut here. Whenever I made one cut here, to make this entire as a cantilever I need to provide this -1 reaction. Okay, and here again -1. So that is 3 into how many number of cuts? C is equal to 1. 3 into 1 minus 1, this is at B, -1 at D. So it will become 3 minus 2, it will become 1. So the structure is indeterminate and degree of indeterminacy is 1. Option 2. Option 2 is the answer. Clear? And now coming to the most important question. It will be frequently asked in the GATE exam every year. Number of zero force members in the following truss is, so there are different, many more number of, so by just seeing how many number of members are there having zero forces. So there are two principles to observe how many number of zero force member. For example, the first principle is when two members are meeting at a joint. Listen this and write this statement. When two members are meeting at joint, and no load at the joint, then force on the two members is 0. Irrespective of inclination, angle between them. Irrespective of angle between them. So I'll dictate. So when two members are meeting at any joint and there is no load acting on the members or there is no load acting on the joint, so then force on the two members is 0. For example, two members are meeting. Whatever be the inclination, either they may be horizontal or inclined. The angle between, irrespective of these angles, the force on this member is 0, the force on this member is also 0. Okay, this is the principle when there are two members. Now coming to when there are three members are acting. For example, when there are three members are acting, out of three members, two members are collinear. Clear? Then force on the third member is 0. So that is, this is 0. Or else, this will become 0. Because this member and this member are collinear. This member and this member are collinear. So by using the second principle, we can able to say, for example, you can see here. I am zooming this picture. So you can see here. These are two members collinear. Force on this member will become 0. Clear? And these are two members. When force on this member becomes 0, there is no member at all. So remove that member. And these two members are 0, then force on this member is 0. Clear? So here you can able to see there are two zero force members. Similarly here, two members are collinear. Force on this member is 0. So remove that member. So after keeping 0 on the member, just remove that. You can assume that there is no member at all. Now in this again there are two members are here. Force on this member is 0. So that is on the left side of the diagram. left side of the truss there are 4 zero force members. Similarly here this will be 0, this will be 0, this will be 0, this will be 0. So just by staring at the truss, you can able to say how many number of zero force members. Clear? So finally the answer will be 8 for this given question. So it is option 3. These principles are very important. So this type of questions will be frequently asked in the GATE exam. And now what is the value of force in Fg? So this member is Fg. Okay. So obviously to analyze a truss there are two methods, method of joints and method of sections. If you will take method of joints, we need to analyze each and every joint. So if he will ask you to calculate any force on intermediate member, so then you can adopt it is method of sections. So the same concept will be used here. I made one cut here. So you can see this. So I am providing this is one cut. So I am taking it is cut one by one. So in this cut, how many members I cut? This is one member. This is another member. This is another member. 3 members I cut. So because of symmetry, the support reaction at A and E are total load is 6 plus 10 plus 6, 6, 12, 12 plus 4 is 16. So 8 will come here, 8 will come here. I am taking sigma m f c, that is moment about point C is equal to 0. Moment about point C is equal to 0. So whenever I am taking moment about point C, what I am taking on left side equilibrium. So entire left side of the section I am considering. So now you can observe there is one 8 kilonewton. This will create clockwise about point C, and this minus 6 will create anti-clockwise. Okay, and 4 kilonewton is passing through this, and this member is passing through that, this member is also passing through that, but only remaining is this will create anti-clockwise. Clear? So there are only 3. So that is RA, that is 8 into the perpendicular distance from here to here, it is 2 plus 1. Okay, it is somewhere here, no, it is 2 plus 1, it is 3. And now minus anti-clockwise, minus 6 into this will be 1 and this will be again 1. So 1 plus 1 it is 2, and minus Fg, that is force on Fg member, into we want this perpendicular distance. Clear? So this perpendicular distance, I will take this diagram, I am erasing all this. Okay, so this perpendicular diagram. So whenever this angle is 30, this angle will become 60. So in the triangle, so this is 30, this is 60, and this will become 90. So we know this much. How much is this? It is 2 plus 1, it is 3. And tan 30 is equal to opposite side y I am taking. So it is opposite side by adjacent side. It is y by 3. So y will become 3 tan 30. So 3 tan 30, that will be is equal to 0. So if you will calculate Fg, okay, so you will get it is 4 root 3 is the value, and this value is away from the junction. Away from the junction means it is a tension. Okay, so 4 root 3 tension kilonewton. So that is option number 1 is the correct answer. Clear? Okay, so here the concept that I have used is method of sections. Okay, and now you can see it is one application problem. So following propped cantilever beam is subjected to 2 different load cases. In the first case, so coming to the first case, I am taking one more diagram here. In the first case, 10 kilonewton load. So this is A, this is B, this is C. 10 kilonewton load is applied at point B, right? And deformation measured at point C is 2 mm. And in the second case, 50 kilonewton load is applied at point C, and deformation will be measured at, so it is I am taking it is delta 1. Okay, this is 50 kilonewton. So according to Bette's law, so there is one law. So Bette's law, at one point the corresponding load and deflection, some product of load and deflection will be equal to the same product of load and deflection at another point. So at point B, what is the load? It is 10 kilonewton. 10 kilonewton. And at point B in the second case, what is the deflection? It is delta 1. And at point C, what is the load? 50 kilonewton. And at point C, what is the deflection in the first case? It is 2. So 10 5 delta 1 will become 10 mm. Clear? So that is load here into deflection here is equal to deflection here into load here. That will be same. Clear? This is application of Bette's law. So that is the law here, it is called Bette's law. This Bette's law is an extension of Maxwell reciprocal theorem. Maxwell reciprocal theorem. So this is the last question. Obviously we know stiffness is equal to load by deflection or deformation, and flexibility is equal to deformation divided by load. So both stiffness and flexibility are reverse. The product of stiffness and flexibility is equal to, stiffness indicating is K and flexibility indicating is 6. Yes. So the product will become 1. If it is taken in the form of a matrix, the product will become an I matrix. Okay, I matrix is option 2. Okay, this is the last question. So these problems are, for looking, they are very simple and looking like a very small problems. But whenever, until you know the concept, then only you can able to solve the problem. Otherwise, you cannot even put 1 or 2 steps for the problem. Okay, so if you have any doubts or else if you need some more information regarding anything, please post your comment at the below. Okay, thank you.